Hello, hello. Long time no see. I've took uh, quite a big, how we say that, time off. Forgot the word for it. So um, I'm back for now. I hope. I mean, I hope more than just for now, but yeah. So I'm gonna start with uh, learning new stuff like in C++. Last thing I did was Advent of Code of last year. That was 4 months ago. That was the last time I streamed, probably. Um, so yes, uh, so we'll learn threads together in C++. I have almost no knowledge of concurrency in any kind of environment, like uh, programming language or whatever. Like I I coded in Java for a bit, but like threads, I didn't touch them. Uh, as far as I know, threads in C++ or even like are pretty hard to understand. Um, Also, I switched to OBS. I hope it it will be overall a better experience. Although I see that for some reason, um, at least the win Chrome here is dim for some reason. No idea why. Let's see. Visual Studio seems fine. Visual Studio seems fine. So what I'll be doing is going through, like, I'll start with Java Point, go through those tutorials and stuff. I'll try to code something that works, I hope, and maybe later down the line, like, we'll build some project with threads together. I thought maybe a server, but as far as I know, there is no like um like sockets and networking special to C++. Like everything is from C, and I don't like it. Like I tried to read about it, but I don't really like it. Um, I hope you can hear me fine. I tested the audio before. Seemed to be fine. Okay, maybe I can. I don't know, get some more. How do you say it? Some more brightness on here. Probably should have done it before start the stream, but oh well. Uh, I hoped something like just with like OBS showing this dimmer, but I'm seeing on Twitch it's not really different. Um, oh, I can't change it midstream, so I hope you can see it fine. Um, from from what I'm seeing, it looks fine, like a bit dimmer, but yeah. Um, okay, let's start. So concurrency in C++. Introduction. The term concurrency describes a program's capacity to carry out several tasks at once. Concurrency in C++ is supported via the thread class in the standard library. program's basic unit of execution, known as a thread, can operate concurrently with other threads. We will go into great detail on concurrency in C++ in this article. I didn't check if that's all they have on concurrency. Let's see. Oh, that's all they have on concurrency. But it seems to be... Oh my god, what the fuck? Okay, it seems to be... seems to be enough to start with. Going through this STL tutorial, non-interesting abstraction strings template. And what category this is? Like, how do you pref lambda expression next currency next? The fuck? That's okay. Okay, let's some reason my ad blocker is not picking on this. Okay. Let's go. So, creating threads. In order to create thread in C++, you must first define the function that will be used by the thread, and then you must create the thread object. The executed function's signature must be void. Here's an illustration of how to make a thread that runs the function foo. So, we have a thread. Function foo is just printing out hello from thread and printing this thread ID. Stud thread t foo. So that's a thread that executes a function. If I understood it right, you must first define a function that will be used by the thread, and then you must create the thread object. Next function signature must be void. So, okay. Now for main thread, stud this thread get ID and line. So that's the main thread, and that's the foo thread. Let's try to write it. Okay. Void print hello world. It's fine. I like making declarations at the top. So, why is am I? No. Okay. So, void print hello world. Why is it like mention definition? Yeah, it's fucking I just defined it. What do you mean? Oh, that should be fine. Yeah. Stud C out hello world from that from stud thread, right? Oh, stud this thread, I think. This thread get ID from thread this, and let's end it with a new line. And so let's go stud thread t print hello world. I'm passing in a pointer to it, right? So I don't have to curly braces, braces versus brackets. Brace, don't remember. So this, and let's. Do I have to? I think I have to join first, right? So let's go with t dot join. I have not clear idea what join is. I just saw it there. I think that's like ends the thread or something like that. And it's exactly right. So hello world from main thread. Let's go with from thread. Okay, so from main thread ID and oops, this thread get ID. Okay, and we can return 0, right? Let's try it. Okay, so hello world from thread ID 10464 and hello world from main thread ID 3092. Not exactly one after the other, but the compiler works in a mysterious ways. Definitely got a reason for that. Okay, so that worked. Let's get back to currency. Sorry, I'm just okay. Where is it? Okay. So I did basically what I did. I did the join after the hello from main thread. I don't think it'll change, but what if I move it here? Sorry, I hope you didn't hear that. And just gave the mic a hit. Okay. Well, first of all, they're much closer in their IDs for some reason. I don't remember if this thread was first to print or not. I guess it should, because it does join and then prints. Okay, the numbers are completely random, like this. But if I move it after join, so move it after join, this prints out first. I'm guessing join is some kind of synchronization. Like after join, I know that this thread finished its work, I'm guessing. I want to try something. Let's go and try printing, say, let's go 4 size ti equals 0, I 100, I, and I don't know, let's perform some mathematical, I don't know, if j equals 1, so j times equal, oops. I hope you don't hear the background noise. So j times equals 2. That won't be too much. It's like 2 to the power of 100 is a lot. Let's go for, I don't know, 34. 32, sorry. 32. And now print j equals, oops, not equals, just j. Okay. So I'm doing, I don't think it's really, you know what, let's go. That's 8 bytes. 8 times 8, that's 64. That's 64-bit number. Let me check this 64-bit number range. Its integer is 2 to the times 64. So that's the number that, oops, that is signed, but this time, I mean, I'm guessing I can just add like 15 here, like another number, and let's just do nothing here. It doesn't really matter. So let's see. Oh, it takes some time. Definitely takes some time. That's a big 4. Maybe that's out of range. Maybe I'm stupid. That's out of range. Let's. I think that should actually be able to read that, right? So. Okay, maybe not. Oops. Let's try this. Maybe this. Okay, let's remove a couple of numbers here. Maybe that's actually too long. That's too big of a for loop. It's still too big. 1, 0. Just a million, maybe. Okay, 1 billion. 1 billion. Oh, it took a little bit, but I don't know what I was trying to do. When let me try again. Okay, I don't know if you can see that, but this prints it first, and this still prints it. Waits a little bit to finish the big ass loop, and then prints the 1. Maybe if I add another 0, take a bit more time. Oh, took much more time, but yeah, we can see that. Okay. No, let's keep going here. So in this illustration, a separate thread created with the std thread function object. Native code. What? Ah, okay, yeah, I'm passing a function object. Native code runs the function foo, while the new thread executes the function foo. The main thread keeps going. So, yeah, before ending the program, wait for the thread to finish using join technique. Synchronization. To prevent concurrency access to common resources, concurrent programs frequently need to synchronize the execution of threads. The The synchronization support mechanism provided by C++ include mutex, condition variables, and atomic operations. Those say nothing to me. I have no idea. Okay, a mutex, which stands for mutual exclusion, is a primitive for synchronization that is used to prevent concurrent access to shared resources by different threads. Lock, and I gotta read this again, I think. Mutex, which stands for mutual exclusion, is a primitive for what is a primitive? Primitive is that like okay. Yeah. I'm stupid. Is a primitive for synchronization that is used to prevent concurrent access to shared resources by different threads. Okay. Lock and unlock are two thread techniques that mutex offers. Other threads are unable to access the protected resource until the mutex is released with unlock after thread runs lock to take ownership of the mutex. Here's an illustration of how to use mutex to prevent multiple threads from accessing a shared variable at once. Okay, so stud mutex, I have to include mutex. Stud mutex int shared equals 0, mutex lock, shared plus mutex unlock. Thread increment, thread to increment, join, shared value is how does it work? Lock and unlock are two techniques that mutex offers. Other threads are unable to access the protected resource until the mutex is released with unlock. So, like, it can access whatever is between unlock and unlock. In this illustration, the mutex is used by two threads to increase the shared variable so that only one thread can access it at once. The shared variable is consequently increased twice with final value of 2. I didn't get what mutex. Does it stop other threads from running? Concurrent access to shared resources, or is it just everything that is between them that accessed is locked? Oops. Why is that on this? I am a SOE. Okay. Let's try, I guess. Include mutex. Mutex. Oops. The fuck did I do? Let's go and what was there? Okay, increment. I just actually give it a random name so I don't have to create new function. So I don't know. Fuck. I mean, I can go with foo. That is for sure. Okay, and let's go with stud mutex mtx. Let's pass it. Foo. Okay, what if I just do how do we call it? Let's print out. Hello from thread from full number include base thread get ID. Just move the microphone a little bit. Okay, so what if I do mtx.lock and mtx.unlock? What's that? Expected ops. So unlock. So if that locks, does that mean nothing else happens beside this thread? If I understood correctly, it's nope. It still does this first. That's full. Okay, so int increment equals 0. That's what they did, right? So increment plus plus and T1, and let's go with std thread T2. So that should be just give, oops, no, T1.join and T2.join. Okay. Out increment. Okay. Oops. Let's print here increment, which then does something. Okay, so 1, 2, and 2. Right. That's what we expected. I think. Yeah. So what they did is increment, and printed the share value. This illustration matrix is used by 2 threads to increase the shared variable so that only one thread. Oh, okay. So only one thing between mutexes can run. If I understood that correctly. Let's try foo and void go. I want to try something. What if I out hello from foo? Okay. And here mtx.lock would see out hello from goo. Okay, and mtx.unlock. So it will be just not good goo. Hello from foo, hello from goo. So it's always foo and then goo. And that's 0 because I forgot to erase it. Okay. What if I don't unlock it? What happens? Love from foo and womp womp. It doesn't unlock. Oops. Oops. Okay, okay. So let's continue. I think I get it. I think I get it. Wait, condition variables. Another synchronization tool used to manage thread execution is condition variables. Two options provided by condition variable: wait and notify one. There's a space, but I'm guessing, yeah, there's a I forgot this thing. A thread that uses wait function on a condition variable blocks until another thread uses the notify one function on the same condition variable. Here is an illustration of how to create basic producer consumer queue using condition variables. Okay, so queue condition variable mutex, we still have mutex, so mtx condition variable queue producer. It's for I from 0 to 9. Yeah, so studio unique locks to the mutex lock mutex white q.push I notify one consumer stud. They didn't close it, or is it like why? It's not complete. Do I have no? Just okay. Let's try and understand from this. So studio Unicode studio mutex lock mtx cv wait. What is a condition variable dot wait lock turn not. What the fuck? In this illustration, the consumer thread waits for value to become available before consuming them. Wait. In this illustration, the consumer thread waits for the values to become available before consuming them. After the producer thread pushes items into a queue, when values are ready for consumption, the consumer thread is informed via condition variable CV. Okay. Let's see again. Two options are provided by a conditional variable wait and notify one. A thread that uses wait function on a condition variable block until another thread uses notify one function on the same condition variable. Unique lock mutex cv notify one. I didn't get it at all. Threads condition variables. Let's go to geeks for geeks. And C++ multi. A condition variable is a synchronization primitive that is used to notify the other threads in a multi-threading environment that the shared resource is free to access. It is defined as the stud condition variable class inside the condition variable header file. Condition need for condition variable. Condition variable is especially needed in cases where one thread has to wait for another thread execution to continue the work. For example, the producer-consumer relationship, sender-receiver relationship, etc. In these cases, the condition variable makes the thread wait till it is notified by the other thread. It is used with mutex locks to block access to the shared resource when one thread is working on it. So I have to use mutex here. In this case, the condition variable makes the thread wait till it is notified by the other thread. The syntax to declare condition variable is simple: suit condition variable name. For that, we use the associated method for different operations. The suit condition variable method contains some member methods to provide the basic functionalities. Some of these are: this function tells the current thread to wait till the condition variable is notified. Wait for. This function tells the current thread to wait for some specific time duration. The condition variable is notified earlier than that time duration, and the thread awakes. The time is specified as relative time. Wait until, similar to wait for, but here the time duration is defined as the absolute time. This function notifies one of the waiting threads that the shared resource is free to access. The thread selection is random. So notify one, another random thread will choose to continue the work. Notify all, the function notifies all of the threads. Okay. Let's see. Sorry. Wait, where's that? Okay. So, mutex mtx, using namespace as stud, of course. So mutex mtx, condition variable cv, data ready false, so that's a boolean function to avoid spurious wake-ups. So we have a producer function. So this thread sleep for seconds too, so I'm guessing that's just single seconds. Lock release, variable to avoid spurious wake-ups, that already equals true. Logging notification to console, data produced, notify consumer when done. CV notify one. Where did my chat is gone? Oh, wait. If wait. Okay. Where was I? Okay. So that's Java point. That's, by the way, that's this. Is that the same? Nah, that's not really the same. So slips for simulate data production, lock release, mutex, lock, mutex, lock guard. What the fuck is lock guard? What did I miss? That's probably something from mutex, I'm guessing. Let's go here. Where's the lock guard? Let's increment blah blah blah. No idea what lock guard is. Did I explain it? I don't know. Let's try to understand it. Okay, so with global mutex and a global condition variable, data ready, to avoid spurious wake up, produce a function working as sender. Okay, so that's just sleeping for 2 seconds, locking the mutex variable to avoid spurious wake up, so that already is true. Logging notification to console, so data produced, cv.notify1. Okay, notify consumer. So is that, oh, that's condition variable. What's the condition here? That's for consumer when done. Okay, consumer will consume the what producer has produced, working as receiver. Consumer locking, so unique lock. That's a lock guard and that's a unique lock. No idea what any of those are. You can read about them, I guess. cv.wait lock, so it receives a lock. Brackets return data ready. Data consumed. This program the consumer, okay, let's keep reading. Maybe it'll be easier to understand. In this program, the consumer uses the condition variable cv to wait until data ready is set to true while the producer thread sleeps for 2 seconds to mimic data generation. I don't get I mean, I don't understand the syntax exactly. Like cv wait until the occurrence that the wait till the condition variable is notified. That's a lambda function. I'm stupid, but like, what does it returns data ready? Like, okay. Let's keep reading. Spurious wake up. Spurious wake up refers to the condition when the consumer receiver thread finishes its work before it is notified by the producer or sender. In above example, we have used the variable data ready precisely to cope with this error. Lost wake up. Lost wake up refers to the condition when the sender sends the notification but there is no receiver in the wait for the notification yet. Advantages of condition variable. The following are major advantages of using condition variables in our C++ program. The condition variable provides a way to signal the thread of particular condition. The sleeping thread in a condition variable is different from the waiting thread, consuming less resources. Conclusion. In conclusion, condition variables are an effective tool for assuring safe access to shared data, lowering contention, and establishing effective thread synchronization in multi-threaded C++ programs. They are commonly used with the mutex to provide efficient synchronization technique. Okay, I need to search about lock guard and unique lock. So lock guard versus unique lock. Medium. Do I have to? Code speedy. In this story, we will learn the difference between stud lock guard and stud unique lock in C++. Before proceeding to the difference, let us discuss stud lock guard and stud unique briefly. The characteristics of stud lock guard are: it holds the lock from the time of construction until the time of destruction. When it is created, it tries to take control of the mutex, which contains resources it is provided. When this control is over, the stud lock guard will destroy and mutex freeze. It is defined under the header mutex.h. So yeah, that's a mutex stuff. Unique lock are: it does not lock as soon as it is created and unlocks at any time within the time it exits. It is similar to lock guard but provides many methods for locking, unlocking, and removing locks. This transfer locks ownership from one instance of the resource to another. Difference between them. The programmer does not have the ability to unlock the lock guard, but he can unlock the unique lock. Okay, the object creation and lock guard and unique lock are as follows. Resource is the resource to lock, and lock 1 is the object. Resource is the resource to lock, and lock 2 is the object. And the constructor of object lock 1 locks the resource, and when the object scope is over, the object destructor unlocks the mutex. The constructor of the object lock 2 locks the resource, and the object destructor unlocks the mutex. The difference is that unique lock consists of various other functionalities. The program has the ability to unlock the resource with the lock object in the case of unique lock. Okay, now let's go over this again. Let's see. Where is my stuff? Okay. No, wait, that's not what I wanted to. Okay. So, producer provides a lock guard, locks this mutex, right? Variable to avoid spurious wake up. So now data ready equals true. Login notification to console. Data produced. Notify consumer when done. So CV notify 1. So let's see. Consumer thread and producer. So consumer doing a unique lock and the producer doing a lock guard, right? So this is waiting for lock this one. Turn data ready. So lock and true or false. So if it is true, then it can proceed. Okay. How does it called? Is it called CV? That's condition variable. So condition variable. Wait. CPP reference. Wait causes the current thread to lock until the condition variable is notified or spurious wake up occurs. Pred can be optionally provided to the spurious wake ups. Predicate. It gotta receive a unique lock. When unlocked, calls lock.lock possible blocking. Okay, so equivalent to while not predicate, wait lock. This overload may be used to ignore the spurious awakening while waiting for a specific condition to become true. Oh, okay, so that's got it, I think. I got it. Let's see what they say about unique lock. CPP reference. Class unique lock is general purpose mutex ownership wrapper, allowing deferred locking, time constraints, cursive locking, transfer, blah blah blah. Unique lock is movable but not copyable. It meets the requirements of move. That's a lot of words. The class unique lock meets the mutex meets the lockable requirement. Unique lock also meets the lockable requirement. Okay. Locks takes ownership of associated mutex. But they both take ownership of associated mutex. Huh? My brain hurts. Holy shit. So, wait. So it locks a mute. Oh, wait. Let's read again about unique lock. Unique lock. Not CPP reference. Maybe this. Unique lock is an object that manages a mutex object with unique ownership in both states, locked and unlocked. On construction or by move assigning to it, the object acquires mutex object for whose locking and unlocking operation becomes responsible. Okay. This class guarantees an unlocked status on destruction, even if not called explicitly. Therefore, it is especially useful as an object with automatic duration, as it guarantees the mutex object is properly unlocked in case an exception is thrown. Now that unique lock object does not manage its lifetime of mutex object in any way. The duration of the mutex object shall extend at least until the destruction of unique lock that manages it. So lock mutex. So that locks the mutex. Also that waits, so there's wait, what was it? So wait, because the current thread to block until the conditional rule is notified or Spurs wake up occurs. Oh, okay. Automatically calls lock unlock. So this unlocks the mutex, right? I mean, unlocks the lock. So this makes the okay. So this is able to take hold of the mutex to lock it. Variable to avoid Spurs wake ups, log notification, and notify one. So notify one, and this receives the notification. It receives notification and returns if data is ready. Okay, I think I get it. Now, what can I do with it? First, I need to include the condition variable probably. Okay. Probably include chrono, or is it already included thread? So stood this thread sleep 4 oh my god, stood chrono seconds 2, it was 2 seconds. Okay, Let's go and create stud condition variable cv, and let's go for a bool flag equals false. Okay, so this will be the consumer, right? So let's create unique lock. So stud unique lock mtf. I'm guessing it receives a mutex here. Oh, stud mutex, right? Which one has the member then? Oh my god. That's using on this. So just unique lock with that. Fuck. Mutex. Stud mutex. Okay. I knew something was fishy. Okay, so stud oops, cv dot wait till pass here a lock and lang. Okay. And after that we can print that we are consuming data. Okay. I don't have to unlock it, right? It's kind of does its own thing. So stud lock guard mutex. Oops. Stud mutex lock and mtx. Okay, so let's see out. Now let's move it here. Processing. Is that how I write processing? Yes. Processing data. Okay. Oh my god. Mutex flag equals true. And we can cv.notify1. Right. Let's even change this to this. Right, so it will... Okay. Processing data, consuming data. Nice. Um, After that, let's make this sleep. I have an idea. Make this sleep for seconds to uh and let's create a lock guard stood lock guard stood mutex. Um, can I lock the lock again? Can I? That's a unique one now. So let's lock G. Okay. And pass it mtx. Okay. So let's have this. Let's change this to data read. Okay. Data read. Then data read. And in here, I'll also create bool data zoom equals false. Show data consume if it's true, and cv dot notify one. Color failing to release lock mtx before control. Okay, so let's go and mtx dot. No, but that's you know what? I don't need this. I already have a lock, right? So this is locked now. It's all locked, and then we can notify one. So I don't know if that'll work. No idea. But let's try it. Bar. So unique lock stood mutex lock mtx cv dot wait. Wait. Oh, yes. Here I'm returning data zoom. Right. So, oops. So I'm waiting for this, and let's see. Out data consumed. Okay. So will this work? Ooh. Let's even thread T3. Okay. So processing data. Fuck. So that's unique loaded. What if I put it here? Processing data, sleep. And this doesn't, it's not able to lock. Wait. CB clock text. Why does that fuck up everything? Unique lock, it waits for lock. Turn data consume. It should be unlocking it for this to process it. Hmm. Two seconds. Wait, what is it? And close. What the hell? Maybe because it notifies one and it notifies this. What if I notify all? Oh, fuck. Okay, that's something. Oh, I'm not joining it. T3 dot join. Processing data, consuming data, data consumed. Nice. That worked. No, no, thank you. No, not interested. Where is it? No, it's keep going. There's a lot. Oh, no, there's not. Why is it so? Oh, okay. Atomic operations. Another method for synchronizing access to shared resources is through atomic operations. An atomic action is one that is carried out as a single, cohesive process without the involvement of any other threads. Let's read that again. Another method for synchronizing access to shared resource is through atomic operations. An atomic action is one that is carried out as a single, cohesive process without the involvement of any other threads. Integers, booleans, and pointers are just a few of the fundamental kinds that can be operated on atomically in C++. Here's an illustration of how to increase shared variable using an atomic integer. Okay. Atomic int shared 0, that's the value probably, shared plus plus, thread, increment, join, shared value is ta ta ta. The shared variable in this instance is an atomic integer which allows several threads to securely increment without the use of mutex. Okay, but I don't know which one increments. Right? I think if I can somehow Well, let's write this, maybe write this with atomic. So let's include atomic, include atomic. So stud atomic boolean data read. Include atomic bool data consume. Okay. In here, no logs. No, that won't work. Will it? Will it work? Like, no. So, okay. Don't need this actually. I don't need a condition variable and a mutex. I can just say while, let's give it false. Identifier isn't what? Oh, it's just okay. False. Okay, so while data read, so just waiting here while read, and here I'll be waiting while not data consume. All right. Data read true. I hope that should work, right? Processing data, consuming data, data consumed. Nice. Yep, okay. That's atomic variables. And I think that's the end of this. So, in conclusion, C++'s concurrency feature is a strong one that lets programs run several tasks at once. Concurrency support method offered by C++ include threads, mutexes, condition variables, and atomic operations for creating concurrent programs in C++ that are effective and responsive. This is crucial to comprehend these ideas. Nice. I think that'll be. I want to write something now in threads. I need an idea though. Maybe I'll ask ChatGPT. Or if someone has an idea what to write with threads. I don't want something too complicated. Just a little project. Yeah. Let me search up. Let me see. Okay, that's way too long. Yeah. I want to know how to include threads. Oh my god, wait. Practice. Sleeping barber problem. Let's see what that is. Actually, why am I searching on this screen? You can see it. Let me. Oh my god. Sleeping. Okay, the problem requires the use of semaphores or other synchronous mechanism to ensure that only one customer is in the barber chair at a time, and that barber is always working on a customer. If there is one in the chair, otherwise the barber is sleeping and the customer arrives. Okay, I can do that, right? Clear the chat. Okay. Did that work? No. So let's do the sleeping barber problem. Let's remove all that, and that. Okay, so we have cus. That's not the right customer. Have a customer. And I should have a barber. Struct barber. I hope my English is fine. Okay, let's. Or probably gotta have an atomic for atomic bool is in session, and let's go with int. I'm pretty sure that's not our right customer. Yeah, with a fucking U, not a customer. And an O. Me English good. That didn't remove it. Whatever. An accessible element is not allowed on this declaration. Why? Oh, it amount of customers. Okay. Let's instructor and here. And we'll receive. I forgot that's not okay. Okay. The customer side, I'm gonna just customer send, like, I'll call it, send a request to be at the barber. How do I send a request? I need to think. So the barber accepts only when this is I know. Right. So not at the barber, it's supposed to be at the customer. So and that's a static. Should be static. So when a customer created, barber should take care of him. So customer sets his in session to true. No. No, 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 no. I'm stupid. This is supposed to be here. Yeah, yeah, yeah. Do I need two of them? Sorry. Um. So amount of customers. First of all, amount of customers gotta be 0 at the start. What was it? Okay. So waiting for requests. How am I waiting for requests? So while true is waiting for requests, right? While true. If is in session equals false. So if not is in session, then I'm taking care of the customer, right? Taking care of the customer. If is in session, then I don't need a struct here, just function like void take care of customer. Okay. And this will just print out working on a customer. Working on a customer. Okay. So if it is not in session, is session equals true. So they're now in session and I can create a thread. God. No, wait. Yes, here. Oops. This should be of customer, so is in session equals true. Okay, and let's give it a wait time. So stood this thread wait sleep 4 no chrono seconds 2. So is in session equals true. Wait. So no. Well, working on a customer, sleeping. So, well, this is not in session. If this is okay, not sure how to structure it even, like, right. So this I'm gonna start a new thread here, right? Oh, in a while I can in a while to maybe start a new thread. So if he's not in session, stud thread t take care of customer. Oops. Take care of customer. If it's not in session. Take care of customer. I plus plus. Oops, I amount of customers. Plus amount of customers plus plus. Isn't session supposed to be first? I think. I don't know how that exactly works. So plus after ends up working on a customer. Is in session. What the fuck is in session equals this, right? Will that kind of work? I think like it should work, but I wanna try also a different approach. But let's try. P.join. Then is in session. Session equals false, right? And the amount of customers minus minus. Okay, let's try it. I don't know. Let's see. What particular customer none? I can static void. There is blah blah blah. Barbara take care of customer. Non-standard syntax use not to create a pointer to member 20. Yeah, let's maybe like that. No. Okay. Scratch everything. Fuck that. Let's try different approach. Okay. What can I do? So we have a barber that waits for a customer. Let's delete everything here. Let's delete everything. So I don't need a struct, I don't need all that shit. Oh. Void customer. Do I need barber function? Main is kind of the barber, is it not? Yeah, let's see my barber. Okay, so void. Okay, so let's create here stud mutex mtx and stud condition variable cv and maybe a bullet also. Aston atomic bow is in session. Okay. Let's go with false. Okay, so barber while true. Wait, how was that? How did that go? What to know? Looking one customer per so stud lock guard lock mtx, right? See out taking care of customer. Okay, also let's go and atomic int amount of customers 0. Setting of customer, amount of customers plus plus, and stud this thread sleep 4 chrono seconds 2. Okay, after that, what else was that? That was cv dot notify 1. And amount of customers minus. Okay, and if amount of customers more than 1 or amount of customers less than 0, let's print the fuck the out amount of customers. Okay, so notify 1 here, unique lock mutex mtx cv dot wait cv.wait lock and return is in session. What? Atomic constant. I can't do that? Apparently I can't. Okay. I guess. Why do I need atomic anyway? Then is in session. So this out. Done. Amount of customers minus. Amount of customers minus. And I have to release the lock, right? Dot. Okay, and in main I'm gonna create some threads. Let's try just, well, first of all, thread barber t barber thread customer one customer, and let's copy a bunch of those, like 4 and 5, and let's join them. What the fuck does that? I guess I'm gonna join them one by one. Okay, I can do better than that though. Okay. What? Copy. Thanks. So 1, 2, 3, 4, 5. The last one is a barber. So 1, 2, 3, 4, 5, and barber. I'm already join. So the idea, it will take care on if one customer at a time. Hopefully. Take care for customer. Take care for customer. 2, 3, 4, 5. Oh, wait. Oh my god. That's not good. It notifies 1, right? It should notify only 1 customer. And is in session. False. Wait, what? Oh. is in session equals false. Notify one. So wait. No. And is in session equals false. Here is in session equals true. So should I unlock it? Wait, no. Fuck. Done taking care of customer. To done taking care of customer. Okay. Maybe it shouldn't start with 0. Why? Why is it getting to 2? Why is it getting to 2? Um. Blah, blah. Session is false, and then you can lock again and do that again, and then only notify one. Oi. Wait. Why is the amount of customers getting to 2? So session. So no, that's not 2. So it gotta start with 0, right? So amount of customers 0. Taking care of a customer is in session is true. Amount of customers. Wait. That. Oops. Not in session. Two. What the fuck? Oh my god. Let me check. Not that. Born. Okay, so barber. Let's see. I want C++. What the fuck? Okay, that's not exactly threads, but let's see that. So barber down, waits for customers, sleeps. Sits, so only one customer tries to sit. Um, Oh, wait. Let's just if not is in session, right? Wanna do that? Let's just okay. So if I'm not in session, I'm doing this. La 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 la. Customer lock wait done. Amount of customers minus minus. Is in session is false. Damn, that works. I hope. I think. Oh, amount of customers. Okay, what if I have instead stood vector. Oops, I forgot to include vectors. Stood vector. So stood vector of threads. Okay. Um so while true. Oh, I forgot to give it a name. Customers. So while true, customers dot push back customer. Okay, what if I do that? In place back. Yeah, okay, yes. So customers dot in place back new thread customer. New customer. I every 2 seconds maybe. Stood. This thread sleep for chrono seconds. Each second, let's give him each second a new customer arrives. Okay. Let's barber first. And this shouldn't. This won't end, so I don't need a join, but no. Uh, okay. Okay. Seems like it works. Okay. Okay. Um Well, that'll be it for today, I think. Um, so I hope I will make more streams. I hope I'll get to do that more. Uh, I currently plan on learning threads, um, but I don't know. Maybe I'll move to something else. If it'll be, I don't know, too boring or too hard. Um, and yeah, thanks everyone for watching, for tuning in, and I'll see you next time. Bye bye.